Crash Course Instrumentation, Episode 11, Follow the Power, Visualizing Energy Flow. Welcome back to Crash Course Instrumentation. In this episode, we're going to do something incredibly useful. We're going to visualize how energy flows in a circuit using something called power arrows. Physics archery! It's a technique that simplifies everything, from understanding loads and sources to troubleshooting and wiring panels. Let's break it down. Break it down now. What are power arrows? Power arrows are graphical tools that show you the direction energy is flowing in a circuit. Think of them like little traffic signs for electricity. If an arrow points towards a device, that device is a load. It's consuming energy. If it points away from a device, that device is a source. It's supplying energy. This idea comes straight from physics and conservation of energy. Energy flows from where it's stored or generated to where it's used or transformed. Why this matters. When you're working in the field, you're often trying to figure out who's doing what in a circuit. Is this sensor supplying power or just signaling? Is the PLC output sinking or sourcing? Which way is the current really flowing? Visualizing power flow helps answer all those questions. It also helps you match polarity correctly, avoid damaging equipment, design more intuitive schematics, improve fault isolation. It's especially helpful when you're working with multiple voltage levels, signal loops, or systems that have floating references. Sourcing versus sinking, the power supply side. Here's where things get even more interesting. Not all power supplies behave the same way when it comes to how they interact with other devices. Sourcing means the device supplies current to the load. Most power supplies and many PLC output cards are sourcing. They push current out. Sinking means the device receives or draws current from the load. This is common in transistor-based inputs and some PLC configurations. Let's use a PLC output module as an example. A sourcing output connects its positive terminal to the load, sending current into it. A sinking output connects its negative terminal to the load, allowing current to flow from the load into the device. Why this matters? If you wire a sourcing output to a sourcing input, it won't work. They're both trying to push current. You must pair sourcing with sinking for proper current flow, like a power handshake. In DC systems, this often affects how field wiring is routed, how commons are defined, and whether shared grounds are appropriate. Example, simple resistor circuit. Let's say you have a 24-volt power supply connected to a resistor. Current flows from the positive terminal through the resistor and back to the negative. The power arrow points into the resistor because the resistor is the load. It's turning electrical energy into heat. The arrow points away from the positive terminal of the power supply because it's the source. Simple, right? Now let's scale it up. Trending for the win. More complex example, PLC input card. You have a sensor wired to a PLC input. Which way is the energy flowing? If the sensor is powered and sends a voltage signal to the input, the arrow points toward the PLC. If the input card supplies current and the sensor sinks it, the arrow flips, pointing toward the sensor. Knowing this helps with wiring, labeling, and diagnosing unexpected behavior. In loop-powered devices like 4 to 20 milliamp transmitters, the power arrow always helps you confirm the path. From supply, through transmitter, through resistor, or analog input back to ground. Field tip. Use it like a flow map. Power arrows are like flow arrows in a piping diagram. They tell you how things move. They tell you what direction interactions are happening. They make complex systems easier to teach and troubleshoot. If you're building a new panel or trying to understand someone else's wiring, adding power arrows to your schematic is a game changer. Even a sticky note with a drawn arrow next to a terminal block can make your future self say, "Thanks, past me." Final takeaways. Energy flows from source to load. Power arrows make that visible arrow into a device equals it's a load arrow. Away from a device equals it's a source. Power flow helps with design, troubleshooting, and documentation. Understand sourcing versus sinking to wire systems correctly. This visual technique is simple but powerful. Coming up in episode 12, we'll explore the types of sources you'll run into in real-world circuits. and how to tell a voltage source from a current source. Thanks for watching Crash Course Instrumentation, bringing power, pun intended, to the people. Don't forget to subscribe, join our Facebook group, and check out the open-source Mod L PDFs by Tony R. Copalt to keep leveling up. See you next time!